Alright, so here we have Jake, and today with Dr. Talaga and Chris Kroll, Curtis Schumacher, we've taken apart the Fanuc Model A1.
Yes, it is the A Model 1 Fanuc robot, also known as the A Model 200. What we did, we had this all encased in solid 3/16 inch steel. So we had to take all that off. We get down to the main frame. We can see that we've got structural supports here and on the other side as well that holds up this guy. That also holds up the frame. These two guys, these are also solid, appears to be possibly stainless steel or some other type of metal alloy. These are really smooth, have little pouches in them that allow bearings. And this main piece of steel down here, they got bearings and a lot of grease, as you can see. And what that allows is smooth operation in the Z-axis direction. We come over here, and we can see that the servo motor right here is connected via belt drive to what you can't see from your side of the video camera. If you want to kind of come over, you might be able to see it better. There's actually a screw type of mechanism right here. This is the clutch for it. This is pretty much a brake that stops it from sinking down when there's electricity not applied. So what we do, we disengage the clutch, we spin the servo motor, this guy spins, and inside of here, there's actually a whole long thing about that long, and it's got a spiral in it that follows this, so when the screw itself turns, the robot lifts up, which lifts this whole system. We come up here, we've got a whole giant gear system here. These things are massive, and I'm not sure the gear ratio, but it's not that much off. So inside of here we have a gear changer, I'm sorry, not a gear changer perhaps, but it's a gear ratio machine in here, as well as the servo motor. So the servo motor spins around 900 to 2000 RPM, and then the gear changer, the gear ratio machine here, changes that down and turns these large gears, which are able to turn the entire machine. We come over here to the actual assembly of the robot. Right here is the arm, where we would have this third servo motor down here, along with the wrist axis. Oh, that's heavy. That's all mounted, all solid steel of course, and when we apply voltage to this servo, the hand spins around. So yeah, that's pretty much what we did today, and also, of course, I forgot to mention, it can extend in and out. So this guy goes in and out using a force servo motor that is found here with the belt drive. This whole thing weighs, I believe in the book, it said 600 pounds, which I find hard to believe. I think it might be even a little bit more than that with all this steel and all these motors. These motors weigh 50 pounds apiece. And then we're going to come over to the console tomorrow, and we're going to start messing with this stuff. The top part is the computer, the main actual computer that does all the calculations. We have ROM, the random memory. What is it? What is it called?
Read-only memory.
What is it? Read-only memory. My bad. Yeah, read-only memory. The CRTC, which controls the video controller here, and BMU, that stands for Bubble Memory Unit. That was used a lot of times in the 70s and 80s. They tried to make it actually so it could be used with mini computers, and it was used in arcade systems as well. However, they were like, hey, we've got this really cool memory, and it's really durable. It's why it's used in industrial systems as well as military applications. They tried to use it in computers, but they realized, oh, we just made hard drives and disk platters, which are way more better. So they decided to use those, and I completely agree with that. But for military and industrial applications, bubble memory is a very, very stable way to go, and it's very rugged and does not erase easily. So we come down here to the power supply, 240 volt, 3-phase. We use 3-phase power. 3-phase power, 240 volt comes in here, goes to the main power distribution board here, a couple transformers, also goes up to this power distribution board, which sends it to the servo drivers on the other side. And then down here it's called the DIDO board. That's pretty much the input-output board. It takes in signals from all the control console up here. Got that. Also takes in signals from the teach pendant, which is laying around here. This big old box teach pendant, all metal. Takes in signals from both these guys, reads them in, and then tells the computer what's going on. Says, this button's been pressed, what do you want to do? Computer determines what to do, sends it back to the DIDO board. And the DIDO board is also used to control the servo drivers, which are found in the back console. I don't know if you want to come around back, I don't know how much room there is. I can unlock it for you real quick. It's pretty crammed back here. There we go. There are four main... Oh, that was loud. There are four main servo drivers. 1, 2, 3, 4. They look to be all identical, and that drives the 4 black motors that we found before. Those are connected to the main computer and the DIDO board, I believe. We're going to double check with that tomorrow. And then we come down here. This is the main transformer for everything. 240 volts comes in, and some of it gets put into here, 3-phase transformer, which supplies the power to the servo drivers. So wall comes in, gets transformed into something that the motors can use, gets put up to the controllers, and the controllers tell the motors how to use it pretty much. And then over here, which is really interesting, this is called a heat exchanger. All it does is bring in cold air from the bottom, it sucks in the air, and it also cools the transformer by that, because this fan is right next to the transformer. This outputs a lot of heat, so it sucks in the heat from that, puts it up, cools it down in here as well, because it's the heat exchanger, blows out cold air up here, and then it's also, the heat rises, we have 2 fans up here that help control and cool the atmosphere and the servo drivers, and that gets outputted up at the top here on the sides. And there's one more fan on that side, I believe, and that's where these guys get connected to, in this little blower system.
Alright, there we have it.
Is there anything else you'd like to ask me?
Jake briefly explaining the entire function of a Fanuc A Model 1.
Yes.
Thank you, Jake.
You're welcome. Hope to see you soon.